Good morning students. Today we will solve few more problems of chapter 3 atoms and molecules. Now first of all question number 1 of page number 32 and 33. In a reaction 5.3 gram sodium carbonate reacted with 6 gram of acetic acid. The products were 2.2 gram carbon dioxide, zero point 0.9 gram water and 8.2 gram of sodium acetate. Show that these observations are in agreement with the law of conservation of mass. So in this question, there is a reaction which is given below. In this reaction, sodium carbonate. How much sodium carbonate? 5.3 gram of sodium carbonate reacts with 6 gram of acetic acid to form 8.2 gram of sodium acetate along with 2.2 gram carbon dioxide and zero point 0.9 gram water. Okay. Now we have to prove that all these observations are in agreement with the law of conservation of mass. Now let us recall law of conservation of mass. As I told you earlier, law of conservation of mass was given by Antoine L. Lavoisier. This law states that mass neither be created nor destroyed in a chemical reaction. So, total mass of the reactants before the reaction is equal to the total mass of the products after the reaction. Okay. So, first of all, we will calculate the total mass of the reactants before the reaction. It is 5.3 gram sodium carbonate plus 6 gram acetic acid. So, the total mass of these two reactants is 11.3 gram before reaction. Then they react with each other to form these three products. Okay, so total mass of the products after the reaction is 8.2 gram sodium acetate plus 2.2 gram carbon dioxide plus 0.9 gram water. It is 11.3 gram only. So total mass of the reactants means before reaction. Total mass of products means after reaction are same. 11.3 gram, 11.3 gram. This shows that mass neither be created nor destroyed in a chemical reaction. It remains same, constant, conserved in a chemical reaction according to law of conservation of mass. So all these observations are in agreement with the law of conservation of mass. Now question number 2. Hydrogen and oxygen combine in the ratio of 1:8 by mass to form water. What mass of oxygen gas would be required to react completely with 3 gram of hydrogen gas? Okay, now for this question we have to recall law of constant proportion or law of definite proportion, which was given by Joseph L. Proust. Law of constant or definite proportion states that in a chemical substance, elements are always present in definite proportion by mass. Okay, for example, in water, hydrogen and oxygen elements are always present in the proportion 1:8 by mass. It means if one part of hydrogen is there, then 8 parts of oxygen are there. If 1 gram hydrogen is there, then 8 gram oxygen is there. Both react or combine in this ratio, in this proportion by mass only. To form 1 plus 8 means 9 parts or 9 grams of water. So this proportion or ratio by mass will be constant, will be definite for hydrogen and oxygen in water. Okay, so if hydrogen is doubled, then oxygen will also be doubled. So overall ratio proportion by mass will be constant or definite or fixed as per law of constant proportion. Okay, so according to law of constant or definite proportion in a chemical substance, elements are always present in definite or constant proportion by mass. So as in water, hydrogen and oxygen elements are always present in definite proportion 1:8 by mass. It means 1 gram of hydrogen requires or combines with 8 gram of oxygen. If 2 grams of hydrogen are there, then it require or combine with 8 into 2, that is 16 gram of oxygen. So the ratio 2:16, just simplify it. It will be 1:8. Similarly, if 3 gram of hydrogen is there, then it require 3 into 8 gram of oxygen, that is 24 gram of oxygen. So 3:24, just simplify it, you will get 1:8, means same proportion of hydrogen and oxygen by mass. Okay, so if 1 gram of hydrogen requires 8 grams of oxygen, then it is obvious that 3 grams of hydrogen will require 3 into 8 gram oxygen, that is 24 gram oxygen. So the ratio or proportion of hydrogen and oxygen will remain same by mass, that is 1:8, according to law of constant proportion. Question number 1 of main exercise. Okay, a 0.24 gram sample of compound of oxygen and boron was found by analysis to contain 0.096 gram of boron and 0.144 gram of oxygen. Calculate the percentage composition of the compound by weight. Okay, so in this question it is given that there is a compound containing oxygen and boron. Okay, 0.24 gram of that compound is given. So what is the total weight or mass of the compound? It is 0.24 gram, in which oxygen and boron elements are present, and these elements are present in 0.144 gram and 0.096 gram in this compound. So in 0.24 gram of compound, oxygen is present in 0.144 gram and boron is present in 0.096 gram. So you have to calculate the percentage of both these elements present in this sample, in this compound. Okay, so now percentage of oxygen by weight in given compound is equal to weight or mass of oxygen upon total mass or weight of compound into 100. What is the weight of oxygen in this compound? It is 0.144 gram upon what is the total weight of the compound? It is 0.24 gram into 100. Okay. Now just remove decimal sign. There are two digits, so we will multiply numerator into 100. Remove this decimal sign. There are three digits, so we will multiply denominator by 1000. Okay. Now just simplify it. Cut double zeros with these double zeros, 10 with this 10, and then divide 144 by 24. It will be 6 into 10, 60. So what is the percentage of oxygen by weight in this compound? It is 60%. So oxygen is present in 60% in this compound by weight. Now percentage of boron by weight in given compound is equal to weight or mass of boron in this compound upon total weight or mass of the given compound into 100. What is the weight of boron in this compound? It is 0.096 gram upon what is the total weight of the compound? It is 0.24 gram into 100. Okay, just simplify it. Remove decimal sign. Then there are two digits, so we multiply numerator by 100. Okay, remove this decimal sign. There are three digits, so we multiply denominator by 1000. Cut these two zeros with the above two zeros, then 10 with above 10. Now divide 96 gram by 24 gram. We will have 4 into 10, 40%. So boron is present in 40% in this compound by weight. Question number 2 of main exercise. When 3 gram carbon is burnt in 8 gram of oxygen, 11 gram of carbon dioxide is produced. What mass of carbon dioxide will be formed when 3 gram of carbon is burnt in 50 gram of oxygen? Which law of chemical combination will govern your answer? See, what is given? 3 gram of carbon is burned, or we can say is combined with 8 gram of oxygen to form 11 gram of carbon dioxide. According to law of constant or definite proportion, in a chemical substance, elements are always present in definite proportion by mass. So as in carbon dioxide, carbon and oxygen elements are always present in definite or constant proportion, that is 3 is to 8 by mass. It means if 3 parts of carbon are there, then 8 parts of oxygen are there to form 11 parts of carbon dioxide. Or we can also say that 3 grams of carbon require or burn in 8 grams of oxygen to form 11 gram of carbon dioxide. It means if carbon is doubled, then oxygen will be doubled. If it's tripled, then it will be tripled. If it becomes half, then it will also become half. Means overall ratio proportion of these two elements in carbon dioxide will remain same, constant or definite. It shows that 3 gram of carbon require 8 gram of oxygen only. So they are always present in the ratio 3 is to 8 only. So whatever change you will make in oxygen, same change will be made in carbon. So that the overall ratio proportion of these two elements will remain same, definite, constant, that is 3 is to 8 as per law of constant or definite proportion. Now in the question it is given that in place of 8 gram of oxygen, 50 grams of oxygen is given. Now it doesn't matter. Why? Because 3 grams of carbon require only 8 gram of oxygen to form 11 grams of carbon dioxide as per law of constant proportion or definite proportion. Means in carbon dioxide, carbon and oxygen are always present in definite or fixed or constant proportion by mass, that is 3 is to 8. It means 3 gram of carbon require only 8 grams of oxygen. Okay, if you are providing 50 gram of oxygen, then it will make no difference because here only 3 gram carbon is there and that 3 grams of carbon will require only 8 gram of oxygen out of 50 gram. So remaining 42 gram of oxygen will remain unreacted because according to law of constant or definite proportion in a chemical substance, elements are always present in definite proportion by mass. So in carbon dioxide, carbon and oxygen are always present in definite proportion, that is 3 is to 8 by mass. It means 3 grams of carbon always react or combine with or burn in 8 grams of oxygen to form 11 grams of carbon dioxide. If you are increasing the mass or proportion or amount of oxygen for carbon, then amount or content or mass of carbon should also be increased, so that their increased amount can react with each other. Here you are only increasing the amount of oxygen from 8 gram to 50 gram, but the amount of carbon remains same, that is 3 grams of carbon. So it will make no difference because 3 grams of carbon always react or combine with or burn in 8 grams of oxygen in carbon dioxide to form 11 gram of carbon dioxide. Okay, so for 3 grams of carbon only 8 grams of oxygen is required. So it will react with 8 gram of oxygen out of 50 gram and remaining 42 gram will remain unreacted. Okay, this is all for today. Thank you. Have a nice day.